Okay, I'm going to pick back up on number 71, so this will be my final video. I have the set A, which is 1, 5, 11, 17, and 19, and a subset means that every single one of these numbers has to be in the original A set. So this one is not, because 13 is not in my original set. B has 1, which is 1, 11, and 17. This one is. And 7, 9, and 17, that one's not. So it looks like we have two answers to the question, and that would be B and C. You find yourself in a very competitive game of darts. If the radius of the bullseye is 1, so that means that's 1, and the radius of each ring surrounding the bullseye is 1 inch wider, what is the probability that your dart will hit the circle? So what that means is that's the radius there, and then I keep going, so that'd be 1, 2, 3, 4. So that would be a total radius of 4. So basically I have pi times 1 squared divided by pi times 4 squared, which would be 1 over 16, because those two, so the probability would be 1 divided by 16, so 6.25%. The next one, given the probability of M is 0.3 and the probability of N is 0.45 and R is 0.7. So if the probability of M and N is this, are M and N independent? So to check that out, I would have to see, does 0.75 equal to 0.3 times 0.45? And 0.3 times 0.45 is going to equal 0.135, and those two are not equal, so they are dependent. So no, the answer to this one is no. If the probability of N and R, are they independent? So let's multiply N and R times each other, times 0.7, and let's determine what that value is. And that's equal to 0.315, so yes, they are independent. The next one has to do with a two-way chart. It says, if a customer ordered onion rings, what is the probability that they also ordered a hot dog? So first thing I need to probably do is I need to get my totals. And so this is 468. Down here it's 252. And then 252 plus 144, 396. And then my next one is 216 plus 108, 324, and then 396 plus 324 should be 720 total. So if a customer ordered onion rings, so the total amount of customers that ordered onion rings is 252. What is the probability that they also ordered a hot dog? So then that's 108 divided by 252, and you can simplify from there. If a customer ordered a side item, so customer ordered a side item, so all of the customers ordered a side item, so that would be out of 720. What is the probability that they ordered French fries? So I need to have the total amount that ordered French fries. So 468 over 720, and then simplify from there. 77, two events can be determined to be independent, and this is just using the formula, and you can figure that out. If the probability of A given B is equal to the probability of A, and the probability of B given A is equal to the probability of B. The probability that someone owns MP3 is 62%. The probability that someone owns a smartphone is 40%. The probability of owning both is 28%. What's the probability of the OR situation? So we have to add the two probabilities together, 62 plus 40, and then subtract the both, or subtract the intersection. So that's going to end up equal to 74%. And let's just make sure I have the right answer. 62 plus 40 minus 28, 74%. Okay, the next one says, using this table, if someone has a job, what is the probability that they have a driver's license? So if someone has a job, what is the probability that they have a driver's license? So someone has a job, earned a driver's license, 36%, because it's out of 100. If someone does not have a driver's license, so does not have a driver's license, no, what is the probability that they have a job? That they have a job. So that would be 12%. Use the information below to answer the question. So the probability of A given B is the probability of A and B divided by the probability of B. So it's 0.25 divided by 0.3, and that is equal to 0.25 divided by 0.3. 0.83. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So that's going to be 0.35 plus 0.3 minus 0.25, and that is going to equal 0.4. And that's the end of the review.